This conference will now be recorded.
Okay, does anyone have any opened? Sure. For general update, we have the 0.95 version of the pinout posted on the wiki. It's in 2 locations. It's in the tracking sheet, and it's also posted alone in the Excel spreadsheet. Please take a look and see if there's if it works for you. If you have any feedback, please let us know. Feel free to just send an email to me or to the mailing list. Anyone who has an answer is please feel free to help answer any questions anybody has. We're not anticipating any major changes, just some minor aesthetic modifications that we're working on, some typos and things like that. For specification, all the electrical discussions, we are closed, so we don't have any more topics from electrical and pinout perspective. We're working on the write-up for the spec. I believe I posted a update last month, so probably sometime end of this week or early next week, we'll have an updated version on the wiki for review. So we can go to each section. So we have 3 major sections for the spec. We have a discovery and sequencing chapter. We have a LTPI, which is renamed from previously MCSI. It stands for LVDS Tunneling Protocol Interface. And then we have mechanical update. Glenn from Intel has graciously accepted the challenge of owning the mechanical section, so we'll have Glenn to do update on that. So the Discovery LTPI work streams, like I said, has been closed for open topic discussions. The mechanical, since Glenn just picked it up about a month ago, so he's working through some improvements and open items. So Tim, are you on? Would you like to?
Yeah, within the discovery context, we've defined I think 4 different power states: pre-standby, standby, S5, and S0, and the criteria it takes typically to traverse any of those power states forward and backwards, as well as every pin has a classification of one of those 4 states as the minimum state in where bias can be applied to the connector. And it's not spoon-fed on exactly how to cause that. There's definitely different types of isolation circuitry, things like chip select or something where you would want it high at time 0, but then you can't really bias it at the connector until a later power state, as an example. So that's locked and loaded, ready to go. It's being put into the spec, a drawing and full description of each one of those states, as well as there's been some tightening of the power constraints, like a narrowing of the 12 volts to a sane level of margin, and as well as a current limit on the the FRU. There's a FRU VCC pin for FRU and an authentication IC if is optional, and that's all that's defined there. And we're just in the editing phase.
Is that it, Tim?
Yeah.
Okay. Casper, are you on?
Yeah, I'm on. So I guess that the biggest change in the last meeting that we had here in public was the change of the name, like provided already by Jen. The new name for the interface is LTPI. The reason of the change was the raised concerns that the previous name was too close to the NCSI, the network controller sideband interface, and the group decided that the new name will be LVDS tunneling protocol and interface. The shortcut is LTPI. The other major decision made by the workstream before it was closed was that the GPIO channel of this new LTPI interface will have some predefined default set of signals, typical for major implementations, but those will not be mandatory to be supported by every implementation. This will be just a placeholder to have all the typical signals at the fixed locations within the GPIO channel to make it easier for interoperation between different implementations. And those are the major changes. Other than that, we are updating the spec with all the decisions that were made along the way, the workstream, when the workstream was working and applying changes to the interface. Yeah,
Thanks, Casper. Glenn, are you on?
Yes, I'm here. Sorry, I was trying to
Yeah.
find the mute button. Okay. Yeah. So maybe I'll share my screen here to just show kind of the changes visually that we're looking at here. Okay. So one of the things that we've done, let me get this oriented correctly. So one of the things that we've done is made sure that we shifted the card edge here on the mechanical board to the left, 3.25 millimeters. And that is enough based on the tolerance analysis that we did to make sure that a DCM 2.0 card would never insert into a 1.0 slot, and vice versa, that a 1.0 card would never go into a 2.0 slot. And so that's ratified and implemented here. And also we're working to finish up some of the other KOZs and things that have been on here. We did approve the notches. These are obviously inherited from the 1.0 spec and from the OCP NIC for the internal locking, but there's some added notches here, and that's still under a little bit of investigation of how wide the notch actually has to be and how close we can get it to the screw. Closer to the screw where there's very likely not components back here is probably the better. And so we're trying to move that, but you'll notice, of course, that the notch still stays within the rail edge KOZ, so it shouldn't affect boards that don't have an internal assembly or locking that come from the outside externally. A few other things. We did look at the handle on this on the bracket and said that would be optional. And really the intent, normally mechanically you would want something to pull instead of a screw, but just due to the amount of components and connectors and real estate that people have on this card and the things that people are trying to fit, the committee thought it better to just make this optional. If you want to use this style as opposed to the internal locking, you can either have the handle there or not have it. And the other thing is this is the custom thumb screw that's on the OCP NIC. We look to leverage that as well. And one of the things is that this connector or this thumb screw is a what we call a flare-in, meaning it is swaged to the back side of the sheet metal so that it really has some retention in case someone pulled the screw instead of a handle or something like that, right? So, so not too concerned about this being used as a handle when it really shouldn't. But so that's there. Other things, I modified the bracket to make sure that in general it matches the OCP NIC bracket aside from the width. But it's essentially the same if you looked at the edges of where the mounting holes are in relation to the edges of the flanges, how those flanges, the depth of the flanges, all of those things that are there. One thing to note is that the depth of the overall bracket, at least on the top and sides, has shortened from where it was on the OCP NIC. And really that's again to provide as much topside height restriction or height allowance, if you will, for components and things to go as high as they can in this area. So that's why that's gotten shortened. And one of the things we're considering is the ability to have not only, let's say, you know, the EMI fingers that you're used to seeing on some brackets, but also a gasket type material that if we could use the same gasket profile on the sides and tops, that would be ideal. So looking to enable both EMI fingers for EMI suppression as well as fabric over foam gaskets. The other thing that I'll mention on the board itself is we looked at the different types of, let me open the board itself here. The different types of ways that a board, this module could be assembled. And one of the things we realized is not only are people inserting it from the outside, but are putting it on a tray and sliding it forward. That's certainly a way someone could assemble this onto a motherboard and then put that into a chassis. And for that reason, you know, as a standoff on the bracket is sliding across the board in this area, we did have a oblong type or ob-round type KOZ here on the bottom for that case. But we realized if you're sliding the card into the host board, that you need that KOZ on the other side as well. So we've basically changed this such that no matter whether you're sliding it forwards or backwards, that standoff is going to have enough room to not knock off components or have, you know, hit surface traces or things like that that could be problematic. So that's one of the things that we've added on the board itself. And other than that, we are still just continuing to clean up some different things. I do have a resource to help with drawings. So we're going to start on the spec drawings here this week, and we should be adding some content to the specification as we move forward. Okay, any questions from anybody? No? Okay, back to you, Chen.
Thanks, Glenn. Oh, so there's one more thing so we're considering removing the vertical form factor.
That's right, sorry.
Support, yeah, from the specification, not just because of the changes that went into the horizontal form factor, and the folks participating in that work group are not interested in the vertical form factor. So if there's anyone who is interested in the vertical form factor, please let us know, and we will also need volunteers to work on that and see, you know, just for details what you know, the size and everything. So
I'm sorry, Shen, what do you mean that you removed that? Are you making it outlawed, not compliant? What do you mean?
we won't document it in the 2.0 spec just because there are changes we made, because we don't know the detailed requirements for the vertical form factor, and we don't have anyone working on it. No one is designing to it. So, it doesn't make sense for us to just make something up, and if it doesn't meet the needs of anyone using the vertical form factor. As you saw what Glenn just showed, that we shifted the gold fingers, we are adding KOZs and notches and things like that. We don't really know what we need to do for the vertical form factor, so we are, instead of leaving it the same as the 1.0, that's actually one of the options, is leaving the same, but then the hard edge shifts and those things need to happen as well. So we need resources to work on that if anyone's interested. Does that make sense, Yamak?
It does make sense, yeah. Thank you.
Yeah. So if you have any models that you would like to provide for us, or the requirements, we'll be happy to put that in. But we need we basically need some help with that. Yeah.
Very good. Thank you.
Could we not use the DC-SCM 1.0 vertical form factor as the basis, or I'm just curious?
We can, but like you just saw, that there are hard edge shifts. Which way do we go with vertical, and the add additional KOZs? What do we do for vertical form factor? So we do need input on that. And
yeah, I guess that maybe the way we should be hearing this is, if anyone thinks that the vertical should be kept within the spec, that there's an ask to contribute the similar type of perspectives that have been invested here with the horizontal, in order to keep it into the spec and with high confidence that it will work. Is that a fair interpretation?
Yeah. So yeah, for those who have signed the CLAs, the mechanical work group meets on Fridays. I think everyone, I hope everyone knows that. And those who have not, let us know if you're interested in contributing. We'll work on that contribution license. I think that is the last agenda item for updates. Any questions open regarding the specification and everything that we said? If not, we do have a presentation scheduled from Library BMC from IBM. This was asked that if anyone's interested in knowing more about Library BMC, and the answer from the group was a yes, so we schedule it for today. Todd, are you here?
Yes, I am here, ready to
Okay.
ready to go. All right, here we go. Let me share my screen. I want to share this. All right, you guys see that all right?
Yes, we do.
All right, perfect, thanks. Yeah, so this is about the Libra BMC project. It's ran by the Open Power Foundation, and it's a completely open effort. I can talk about that more at the end. And what we are attempting to do is remove the have a completely open BMC solution versus using hardware from a vendor like an AST 2500 or some such thing. Instead, we want to use an FPGA so that everything, you can completely inspect the contents of the hardware, and then also roll changes to the field if you would need to. So what we're doing to sort of do a proof of concept on that general concept is we're taking an IBM AC922. That's the big servers there at Sierra and Summit, the big supercomputers, and we have an existing BMC card in there. We're gonna pull that out and replace it with a card that has an FPGA on it, and everything again is completely open. So it's using the open power ISA. The core is open. That's the microwatt core. All the peripherals, Ethernet, whatnot, are open with LiteX, and then the firmware is Open BMC firmware, which does already run on the card that goes into the existing AC922, but we'll need some modifications here. And then the next plan, it would be to use have to support the DC-SCM and DC-SCI standard. That's why this would be interesting to this group. So complete openness is the goal to reduce that attack vector. Now, where we're at. Well, okay, so this is a picture I drew a long time ago that shows all the different connections that you have from that BMC in the middle out to the various components on the planar. So obviously you would expect all of this, right? Your fans, your power supplies, your VRMs, P-goods. You're getting your load via PNR. You got an LPC interface talking to the host. We have an FSI interface, which stands for Through Service Interface. That has also been opened up. That was formerly not, but now that interface is part of the Open Power Foundation as well. That talks into that little self-boot engine. Anyway, you much like you would have on an Intel or any other type of architecture, there are a lot of connections from that BMC card to various areas in the planar, but none of it is standardized today. So another view of it looks like this. Neither of these are really complete. They don't show all of the connections. But we have a card in the AC922 called the Box Elder card, and it uses it plugs in via a 240 pin Molex connector. This does not conform to the DC-SCI interface, right? It's just IBM created, and then it talks over to this planar and does all the things it needs to do to boot that system up. So this first step we have taken is we wanted to prove that an FPGA has the power and everything it needs to in fact boot an AC922. So you can see we didn't really change from this picture. We were running Linux kernel OpenBMC. All the apps are OpenBMC, device drivers OpenBMC. So everything's open, and we were just running on an AST 2500. All we did here is we changed that to an FPGA. We're using the Arctic 7, and we put use the microwatt core instead of course, the core that was on the AC or on the AST 2500. So here's how we did that. Some pictures. So this is what the card looks like. This is the Box Elder card that plugs into the planar, and there's that 240 pin connector right there, the Molex 240 pin connector. So we took that. I didn't do this. It was done by my colleagues at IBM. We did a breadboard and put an Arctic's RDA7 there on that FPGA on that. Did some careful soldering and wired that all in. And you can see all the connections there in the back. There's the connector again, and then we put it in the chassis. So that's where the old Box Elder card went. Now we've got this new custom card, plugged in. Again, doesn't conform to the DC-SCM standard, but we did do a proof of concept on it to show that would work, and it in fact did. We now have that Linux kernel running on microwatt. We don't have everything implemented like FSI and I2C device drivers on that FPGA, but we were able to just bit bang all those things, and by doing so, we were able to do the fan control, get all of our debug connections running, and implement that LPC interface. With the result being, looky there, it actually booted. So that's Mike Ewing from IBM. That's a screenshot of his screen. Fans can be controlled. We go up, you poke the self-boot engine. It loads everything up, and verily you can boot that system. Again, not full function. The OCC interface and all that isn't running, but you can boot it and run the system with fan control, so it stays cool. So on that front, a lot of cleanup. It's not complete, like I'm saying. We have we have to be able to make it faster. We have to add FPGA, full support, and looking for the full OpenBMC software stack, right? So we can run everything you could do on an AC922 from a BMC perspective, getting all your sensors and whatnot. We want to prove out that works, so we have enough horsepower in that FPGA to actually do it. And now what's more interesting to this group is then we're doing this. So Antmicro is creating a card that has that FPGA on it, and so it looks much like the other block diagram, except it's a real card, not a breadboard thing. They have that card done, and so it does support the DC-SCI interface. But of course, we needed an interposer, which we also did. So we created this interposer. So you would plug that card into the interposer into that same planar on the AC922, using that Molex 24-pin connector. So I have the interposer and of course an AC922, and I proved that plugs in and it works. But what we don't have today is all three of these things at the same location in the world. So I have the interposer and the planar. I don't have the DC-SCM card. Micro has that and the interposer, but not an AC922. Anyway, the next step in this process is put all of these pieces together and prove that an actual production card with that FPGA can boot that AC922.
Is the interposer a passive device? Does it have any electronics on it?
It's passive. Yeah, no electronics.
So a cabling technique doesn't support what you need, since the DC-SCI connector supports cables?
You're asking, could we use a cable instead of an interposer?
Yes, and go directly to your planar.
Yeah, I think we could probably do that. I'm pretty sure that interposer is passive. Let me think of what's on it.
I believe there's a couple active components.
Yeah, you're right, dear. There are a couple things on it. It's not quite totally passive. But the whole point of it was to do that. But I think we had to change some redrive some things maybe, Jerry. I don't know. I wasn't in on the design of the interposer.
Yeah, I was. So I'm familiar. Yep, that's what it was.
Yeah, so we had to change the driver. So yeah, you couldn't probably use a cable. Any other questions about that?
Yeah, so is your goal to maintain this solution based on FPGA, or it's a kind of interim solution, but you are targeting ASIC or SoC with the LibreBMC?
Not sure I quite followed it. Is the question?
Yeah, so is the LibreBMC targeted to be working on an FPGA always, and this is like tied to Arctic 7, or what's your plan related to this project?
Okay, yeah, definitely FPGA always, right? That's the whole point. Instead of using some other silicon, so you could actually inspect everything that's going on in the hardware. Not necessarily Arctic 7. So the goal of the project is we would have many different FPGAs. I see Marshall's on here from Lattice. We would use any FPGA. But the whole goal would just be, hey, let's open this up such that you can build your own card, and you can use everything that's in the open source today to use it. We're going to give everybody a leg up on that, and you can build it with whatever FPGA you want and put it into your system.
And what is roughly the microwatt performance related to the ASICs when running OpenBMC Linux? I mean, do you have any DMIPS per megahertz that you could share, or?
I know we know that. I don't happen to actually know that answer right now. Sorry, I can reach out to me on email or something. I can get you that information, but I don't know it offhand. But yeah, that is certainly a couple of challenges here are the microwatt footprint. We would like to shrink that down so you can get more cores on an FPGA. That's what's one of the goals of the project. A near-term goal that we need to get the performance up. We want to be able to prove that Microwatt can in fact boot to Linux in X number of seconds, right? And we haven't really proven that yet. So that's the performance and the size of Microwatt are concerned. And, this wouldn't even really have to use Microwatt, right? That's what we're using because it makes sense to us. We understand it, and it's we think it's a good solution. But the goal would be you could use really whatever open core you wanted.
And the goal is always to maintain it as a soft IP for the core running the OpenBMC, or you also accept the solutions with a hardened cores?
Hardware core being you buy off the shelf silicon.
Well, there are certain FPGA SoCs that already have hardened cores in it. I think Xilinx also supported PowerPC at some point in this kind of configuration, and the Virtex Pro series in the past. But that's just an example of an FPGA SoC that have a hardened core instead of paired with FPGA fabric.
Is the hardened core open and completely inspectable, or is it just
no?
No. So then
no.
that would not be.
Okay.
Yeah. Definitely the goal is everything's open and inspectable. That's the point. So yeah, if someone throws a proprietary hardened core on there, then who knows what that's doing, right? So it kind of defeats the goal of the project.
Todd, has the DC-SCI as an interface been sufficient and properly defined for all the things you've wanted to do?
Yeah, Jerry, I think so. What's your opinion on that? You've been following it.
Yeah, I haven't been able to check lately. There was a predominantly, I can't say it's 100% that can be followed, but I know that was the goal. I don't know if it was quite achieved though.
So I mean, one of the things we had added was FSI. You guys are probably aware of that. That wasn't there. As far as I know, everything else that
No, the FSI is in the interface though now.
It is, but I'm saying it wasn't, and we asked for it to be added, so that it would, so that we could use it for power. So from what I looked at, I didn't see anything that was missing, or we haven't run into anything yet. That'd be my take on it, Jerry. But
you're good with LPC drop?
With not meaning no longer supporting LPC?
Yeah, that you'd need to do a bridge or prox evolve.
We're good with that going forward. Yeah.
Okay.
I mean, we had to use LPC here on the AC922 because that's what it has. But yeah, we're fine with dropping LPC.
And how about the form factor? Was the form factor sufficient for what you needed?
The form factor worked for the AC922. There, if you think about going forward, we might have some input on form factor for the future. Really nothing to do necessarily with LibreBMC, right? I mean, with LibreBMC, we're not that concerned about the actual form factor. But when you start talking about fitting the DC-SCM card into a variety of different servers, then the form factor becomes a discussion point, I would say.
Right. So as we have discussed in the past, the interface is the first thing to tackle, then the form factor and system around it. So hopefully that is in front of all of us to build that modular hardware system around DC-SCM. Hopefully people will participate in making it a successful story.
Yes, I agree.
Yeah, I mean, to me, the goal is if we can get the other parts right, the form factor could change over time or by vendor, right? That seems like one of the least problems.
Yeah, as long as it doesn't have to fit. That's a good point, Paul. As long as it doesn't have to fit into a particular form factor. If you say, all right, you got the interface, the connector, then as long as a particular vendor can say, well, I'm not going to use that form factor. I'm going to use a different one that fits into my server. That's fine. If the standard says, oh no, if they could do this, in order to use the DC-SCM interface, you have to use that form factor, that would be a problem.
Yeah,
Thanks.
that should not be a force fit form factor. I hope DC-SCM 2.0 is not that way either. About 10 minutes ago, we talked about a particular form factor for planar. It's just because people have had time to describe it very well. Other form factors are possible as well, as long as subgroups get together and define it well.
Yeah, so I listened to that conversation. That was interesting. So yeah, right now I get it that vertical form factor, for instance, isn't a part of the standard. But if somebody, even outside of this work group, would say, well, I'm in my server, I'm gonna make a vertical form factor, right? They could certainly do that. But what would be best is they do that and then participate in the work group and come up with a common solution that would work for many companies. But I don't think there's anything stopping them from just making it a vertical form factor, right?
Right. Essentially, one of the one of the things we can take advantage of by working within OCP on these topics is that once the specifications are clear, people can design to the base specification and contribute their designs so others can implement them and perhaps even provide feedback and make them better. So
right.
If a particular form factor is useful and somebody works through the entire effort of designing to that, of course, as part of the OCP openness, it is great for that to be contributed to OCP as well.
Yeah, I agree with that. I think that would be great because then you can have some, a company out there that creates this, right? And here's the DC-SCM card that they build, and then other companies can pick it up, and they don't have to do the work to design that. And that's one of the good outcomes of this. It'd be it is a common form factor, would fit in a variety of servers.
Okay, so other aspects of DC-SCM as the module. So FPGA, does it take on the duties of BMC and root of trust and other things that are expected of DC-SCM?
Yeah, so that's a good question. Can we put in general? Yes, right. For here, that's what we want to do. FPGA takes over the entire role of the BMC. But then, as you think about root of trust, do we roll that into the FPGA itself? That's certainly one option. Or is there a separate root of trust chip and the FPGA interfaces to it? That I don't think I think the jury's still out on that. Would be the point. I think if it was inside the FPGA, that'd be better, right? You just have one component. You don't have to have a separate root of trust chip. I know Robert Singer, you're online here. What's your take on that?
Yeah, I think the FPGA could probably take the role of the root of trust.
So yeah, that would be I think a good goal. Go ahead.
So for that to be successful, then at some point, perhaps not as part of this work stream, but at some point, we need to engage and make that one standard as well within OCP.
Yes, I would agree. That's not. I think that's a good goal, but yeah, it's not a part of LibreBMC today, and nor part of the OCP. So we would need to add that as a separate effort.
I mean, to me, CMAC and others, I think the key to me is making sure that we don't do things that either explicitly preclude or just make these other alternatives difficult as we go forward. Right? That lets us have some sort of experiments going on in parallel with then feed in easily. Is that a good way to think about it, or is there something else?
That's perfect. That's perfect. Basically, what I'm outlining is the path forward for accumulated knowledge and snowballing all the wonderful work that we are doing. The interface is important, that form factor, many ingredients that go into that form factor, all within standards. And okay. Allowing differentiation. Differentiation is important, either because of form factor or even thinking. As long as it is clear and we snap into some standards instead of making everything free form, let us just have a few standards.
Okay.
Yeah, I like that. I like that vision as well. I think that's the right approach. Okay, good.
Yep.
Any other comments?
Yeah, one more question. So with the DC-SCM 2.0, we're introducing this LTPI interface, which is LVDS-based serial interface for tunneling of GPIO, I2C, UART, or any other custom interfaces. Did you look into that in the context of LibreBMC and supporting it by the LibreBMC in the future?
I didn't. I mean, I understand what you're doing there, which is a better way to do those GPIOs and serialize them and everything. But I didn't really. I guess I didn't think about it in terms of LibreBMC. But it shouldn't. That should be fine, right? I mean, it would just be, well, does the FPGA, can we make it support that interface? And I would think we certainly could. It doesn't today, right? But
yeah, absolutely. Today we are putting CPLDs in order to support this interface. I'm just asking because with this type of architecture, you might have the LVDS built in basically, right? And much more integrated with the BMC function than we have today in the typical configuration.
yeah, and that would be great, right? You put that on the FPGA as well, for sure. And somebody would need to write the FPGA code to make that happen, right? But yeah, that would be definitely the approach. And I don't see that as being a space problem or anything or performance problem for the FPGAs. So I think that'd be the way to go.
Okay, Casper, is part of the DC-SCM 2.0 plan to provide reference designs for that interface in the form of RTL that people can grab and go?
Yes, that's the plan. Absolutely. I think that the interesting point would be the integration of this interface entirely in the BMC SoC, in this case here in the FPGA, right? Without any additional interfaces connecting BMC to the CPLD as a bridge, right?
Right. So if I understood it correctly earlier, DC-SCM 2.0 plan is to include that interface as part of the spec. So once it's contributed, that spec is also part of contribution to OCP, right?
That's right.
Just to clarify, the timeline of the reference code may not exactly line up with the specification contribution. We'll try to align them, but no guarantee that it'll align.
Okay, that's good to know. Thanks. But if I may go back to kind of the concept though, Casper, to me, I think that this really gets us out of the bind that we had earlier when you were asking, are all the signals that we need available? This to me gives us a way out that we can really expand the signal types or even the low-level protocols as we go. That's the intention, right?
Yeah.
Exactly. And what enables that is that there are programmable devices on both sides of the interface. On the planar, as you call it, perhaps the more generic name is HPM. There's also a CPLD or an FPGA that receives this interface, and that device is basically abstracting what the SoC might need. Whatever HPM needs can be abstracted by that programmable device.
Exactly. And the team, parts of a team I'm on have used that in a previous generation, not the one that Todd's talking about, a previous generation of some supercomputers in it for just that purpose, right? We knew we couldn't predict the future, so we built in that flexibility, and then we didn't have to. So I really like the way this is going. I think it's a good path forward.
Very good.
All right, I will just wrap it up then. So this is again Open Power Foundation, completely open, no CLA, CDA, any three-letter acronym. You can just come and participate. We have 2 meetings, meet every other week. So one of them's in the European time slot, and one's for Australia. I run one of them, and then our colleagues at Micro run the other one. And you can go look at them right now. The agendas and recordings are public. Another interesting thing is you can now buy your own AC 922 for for cheap. These, they used to be quite expensive. These don't have GPUs in them, but if you want to experiment with this, they're under $5,000, and you can just go to this link and buy one, which I think is pretty cool. And then I just, of course, have the standard links down here. We do have an FPGA benchmark doc. Tim Ansel from Google wrote that, and you can look at that here and see what we're looking to do, for this. What do we want this FPGA to be able to do for us? To meet what performance and footprint do we want it to meet?
Do you feel comfortable mentioning the companies who are collaborating with this topic so the rest of the team knows?
Yeah. So it's Antmicro, it's Lattice, Google, of course IBM, Oregon State University. They're listed too on that. If you go, I might be forgetting somebody, but those are the Raptor, of course. So if you go look at that link, you can see the voting members. But I think I got them all. So yeah, come and join. It's a good time. So that's all I have.
Thanks, Todd. Anyone with questions regarding anything?
This is Marshall from Lattice. It might be helpful to have a slide which lists all of the open DC-SCM related programs, because it's a little confusing, and at first it appears that they're in competition with one another, but they're not, right? They're intended to work together. So OpenBMC is the firmware that would run on a LibreBNC based solution, for example.
Of course, it is a very good idea to do that, but it seems that there are different sets of people are working on different aspects of it, and maybe not everybody knows about everything else.
Yeah, well, yes, and of course you don't have to use all of them together, but my point really is that they're not competitive programs, right? They're complementary programs. When I first saw these, I thought we had to choose. Well, is the IP development on LibreBMC going to be superior to the IP development of OpenBMC? But it's simply not like that. That's my point.
Yeah, that's a good point. So I should I'm going to give a similar talk to this at the OCP summit. So I'll throw something in there like that to make it clear.
Yeah, I think that's a great idea. I think maybe probably the wiki will have a section on the open development that various groups are working on, and we'll list them. So there is one place for information that goes for anyone to join or participate in any of these groups. Is that along what you're thinking, Marshall?
Yeah, I mean, I would say I'd put it in slide number 1. These are the various open programs relating to DC-SCM. One is the spec, right? Just to help the viewer understand that these are really not competitive programs, because that's what I thought when I initially looked at them, and it was certainly a little confusing to me. Yeah. I confuse easily.
Actually, we do have an overview session of that as part of the server track, the afternoon of second day. If you like, if you have a consolidated list of things, and if you like, we can include that slide there as well, so people know where to go. We can send them to the wikis. We can send them to any resource that you have. If you consolidate such a list, send it to me. I'll include it as part of that slide.
I'll try to build it. And like someone was saying, I don't necessarily know all of everything that's going on because it is separate work groups. But I will. I should know more. I should be able to figure it out. So I will make a slide and send it to you, and then we'll go from there. I'll put it in my pitch, and you can include it there as well.
Yeah, very good.
Very good.
Definitely.
Okay.
So Todd, should we put the presentation you just shared on the wiki, or do you have a different version that you would like to post on the wiki, or categorize as Marshall suggested in the
Yeah, I'll
open
tell you what.
collaboration?
Yeah, I'll make some updates to it, clean some things up, and then I'll send it to you, and then then we can certainly post it.
Okay.
All right.
We're getting close to the top of the hour. We have a few minutes left. Any more comments? Okay, I think we are done for the day. Just a reminder, Summit is in November. If you have any demos that you would like to participate in the demo booth, the hardware management, actually, yes, the hardware management as a whole has a demo booth. I think it's already past the deadline, but if you have anything, let us know. Okay, thanks everyone for joining today. Meet again next week.
All right, thank you. See you.